Welcome everybody to this video. Now we want to talk about the characteristic properties of hybrid models. And here this is interesting, okay, how does this model behave if we extrapolate certain factors, if we interpolate certain variables and so on. So the basic question is actually, will the hybrid model still perform if? And the first question we ask ourselves, if we change the temperature T. So it is important to recognize that the temperature is used within this data-driven submodel part in our hybrid semi-parametric model. So therefore, the scenario from the experimentation would for sure look like something like that. We have our temperature, we have our time, and then we might have 3 levels where we measured the temperature in some experiments for our static experiment, and yeah, where we basically know how this data-driven model operates. And therefore, scenarios where I work within this area between these 3 levels should be fine usually, because this is what we call interpolation. And data-driven models can be interpolated usually. You only get a problem if you start to extrapolate the model. And this is basically what happens if you would set some experiments or some simulation out here, because then we would talk about extrapolation, and this is not supported by the data-driven model. So, but interpolation is fine, so we can only change T within the tested or the trained limits. Okay, so for T in the data-driven model part, interpolation fine, extrapolation is an issue. But what happens actually if we change the incoming volume flow? There we can draw another diagram. And this is 2. Again, over time, we did our experiments. We might have, again, 3 levels. And now what you can do, since v.in is not the data-driven model, but it's in the first principle model, you can actually go usually beyond these boundaries. There is also an area for first principles models where it's getting bad to extrapolate that far, but usually it's fine to extrapolate to a certain amount. And for the hybrid semi-parametric models, this is called a range extrapolation. since we are actually extrapolating a variable which was varied also in the experiments, but we take it beyond these boundaries. And basically we can go beyond the trained flow rates for v.in. Thirdly, now we talked about these two factors we varied in our experiments: temperature, volume flow. But what is if I actually change the tank size A? So the question, will the hybrid model still perform if we change our tank size or the tank diameter, cross-sectional area A? Now, what happens in this case is that we again could say, okay, we measured some experiments that would look over time like this. But here we have A, and our A for one experimental system will usually be constant, so we don't change it. And what we do if we change it is then that we extrapolate in this dimension. So this is then called a dimensional extrapolation. And basically what we can say is we can change the tank size and the model is still valid. And it's very important to recognize at this point what we did in the other video, where we introduced this outgoing mass flow and said that this might be equal to the density times the area times this F2 from T dot dot. Because this allowed us to make this description of this mass flow independent of the area. If we would have said that this is equal F1 from T, comma, some things else, clearly for this tank, it would happen that the mass flow which goes out of the tank depends on the area, actually the cross-sectional area. And if the sun is shining on a bigger area, you will have more mass flow leaving the tank than if it's quite a tiny area. So this shows actually that you should choose your models quite intelligently. And in the end, you might also ask the question, what does actually happen if, or will the model still perform if we change v dot in dynamically? So if you change it over time, then you will see something like this. Again, we have our measurements we did over time. And just like there, we might have measured with some constant values. And what might happen then, or what the model also does allow you, is actually to do something like this with the v.in in your simulations. So a dynamic change. And this is called then frequency. Extrapolation. And basically what you see here and in the model is that you can change this. So we can change v.in dynamically since v.in is connected to the first principles part of the model, and this allows to do some extrapolation also in the frequency area. Now, one question for you might be, 5, will the hybrid model still perform if we change the filling time, TF? So the time where we put in liquid into the tank. Does this influence anything? You answer this. Thanks for watching, and I see you in the next video.